It took me few weeks to understand. All right. Of course, you can understand it fast with all the background that you have, but you know, uh, and you won't find this in this information many places. Uh, I don't know why, but like Berkeley's website, you can't get this, right? I mean, it's not really there. Maybe it's not part of syllabus in many places. Okay, let's start. Okay, so what we are going to study today is IPSec protocol. All right, and these are the contents. We'll go one by one to these concepts, right? So now what we have seen in the last class. Okay, we have seen IP address can be spoofed. Source address and destination address, source address, right? In particular, you can create a packet with somebody else's source address. Okay, so because of this, you can do all kinds of manipulation. Okay, including a man in the middle attack, MITM. Okay, apart from that, IP packet is all available in plain. This is the header and this is the content. The content is visible. So Mallory and all the routers in between have access to this. Okay, so it means that any node or any router in between can modify these contents. Okay, all right. So upon all right, so now we need to take care of it. Anybody can change the header also. So how do we take care of it? All right. Now we can do these things, whatever techniques we are going to apply at the network layer. It means that IP protocol layer, IP packet layer. It means that we need to somehow modify the packet format, or even without modifying the packet format, we need to do something. Okay, and then we can apply all these security techniques that we studied so at higher layer, application layer. Okay, or even at transport layer. Okay, transport layer of course is not shown here, but it can be done also at transport layer. Okay, all right. So what we are going to do is today we'll do it at IP layer. Okay, now if you do it at IP layer, everything above is secure then. All right, because security is coming at the main layer, which is IP layer. All right, and now we have already seen that the concept of one source sending it to a destination, or Alice is sending it to Mallory. Alice is sending it to Bob, and is passing through multiple nodes, which we can call it insecure channel. And Mallory can be anywhere. It could be a router that's malicious. Okay. So now the question is that how do we achieve whatever we want to achieve in terms of security? So what do we want to achieve? If nobody should see, or Mallory or Trudy should not see our content, okay, and they should modify it, then we should have, basically what we are trying to achieve is confidentiality. Okay, and then whatever is being sent should reach as it is without changing, then we say we are achieving integrity. Okay, and the same, the source, if D's or Bob is receiving from Alice, if it actually receives from Alice, then we are achieving authentication. We will use the techniques that we have studied here. All right. Okay, so now let's design. I will ask you to design now IPSec protocol. We want confidentiality, integrity, and authentication. Okay, let's go ahead. So suggest what you are going to do. You are the designer. Who's going to tell me? Okay, I want answers from you. Just don't sleep. Who can tell me what are we going to do?
Like, can we use the techniques we studied in cryptography to basically achieve the
Of course,
CIA?
yes. There's the only way to achieve confidentiality is what? Encryption.
Right.
Okay, now we are sending a sequence of packets, not one packet, right? When you're doing file transfer or transfer of something else, then what kind of a mechanism you are going to use? Encryption is necessary for confidentiality, right? So confidentiality, encryption. What kind of encryption? Because it's not just one message they are transmitting. Then you can do it with asymmetric key encryption, right? If it's just one message, you can use one of the 3 algorithms, RS algorithm you can use. Right? When you have a lot of data to send, what encryption algorithm we use? Symmetric
Stream
encryption,
cipher.
right? Yeah, symmetric encryption. What are the symmetric encryption? You have studied, right? We have studied at least 2. You should know the names of the 2. AES, DES, right? These are standard, right? So now you decide that, okay, when Alice is sending message to Bob or Alice machine is sending to Bob's machine, all the data that's going, which is basically IP layer, if this is a header and this is a content, so all these should be encrypted. By what? By symmetric encryption, say AES or DES. Now what AES and DES requires? Keys, right? Symmetric keys, shared keys. So there has got to be key generation. Fine. Okay, there is a simple thing. I mean, you pseudo random number generator, you can generate keys. But what is more important? Both, and in order to use symmetric encryption, both ends should have the same key. How do you going to distribute the key or send the key to Bob? What is the algorithm?
Diffie-Hellman.
Yeah. Pardon?
Diffie-Hellman.
Very good. Diffie-Hellman algorithm. Okay, Diffie-Hellman, we have not though studied multiple versions are available, multiple types depending on what security you need, right? 1, 2, 3 or whatever. Very good. So we have solved the problem of encryption. Okay. Now, of course, there are a lot of things are to be negotiated between both ends, right? Alice and Bob's machine. What algorithm we are going to use, AES or DES? Then what is going to be the key size? Of course, that will come from AES DS version number. And then what key exchange protocol we are going to use, like Diffie-Hellman. Okay, so these are the things that Alice's machine and Bob's machine will negotiate. So there has got to be negotiation of parameters. Cool. Now, how do you achieve authentication? Oh, integrity, let's see. Is basically both integrity and authentications in some sense, right? It's not truly authentication, but at least source, if it's coming from Alice, actually coming from Alice, but non-reputation, of course, we are not trying to achieve here. But so what are the techniques for integrity? Anyone? We have spent at least 10 hours studying integrity, and protocols are the same which you have studied, right? What we are doing is bundling them in a protocol. How do you check whether message that is sent by Alice reaches as it is, and if it is modified by Mallory, then Bob will detect it. So what are we
Can we
going to
use
do?
We use
Pardon?
Mac. We use
Very good. Excellent. We are going to use
message
Mac.
indentation codes.
Very good. Excellent. I'm very, very happy. Then what kind of Mac we are going to use? Now we want also efficiency, so we are going to use HMAC. You know, HMAC, you take message, then hash it, and whatever hash you get is a fixed size, then you encrypt it using key, right? So this is the code or tag that goes to other end, and the same key is available to other end, and Bob also uses that key and then verify. Okay, so now of course when you say HMAC, then we also need key. Okay, so H key let's call, and this H key has to be sent to Bob also. Bob should have same key, right? Only then Mac will work. So what are we going to do then? It means that again we have to use Diffie element, right? To exchange the key for Mac. Cool? Okay. Now when Alice and Bob's machine is negotiating parameter, they will also negotiate parameters for Mac. That HMAC is to be used or whatever, and what is going to be key size, etc., all that, right? So all this negotiation of parameters has to happen so that Bob's machine know how to decrypt it, okay, or how to do authentication check. All right. What else is needed apart from these two? We are still in design phase. You know, think yourself
There
as a
need to be a
designer.
policy for the protocol.
Yes, policy of course will be there. Very good. Very good. We'll come to policy. See, apart from the integrity, we also may require authentication, source authentication. Now here Mac HMAC, because you know it's Alice key, Alice is generating key and sending it to Bob, and so in some sense authentication is being done. But higher level, if you need higher level authentication, then you can use digital signature, which is for non-repetition, or digital certificate. Now, Alice machine may get digital certificate from CA, can use it. Of course, these two we are not going to discuss, right? Because a high level protocol may take care of this. So let's not worry about this. So let's now worry about encryption and integrity. Are you done with it? Anything else? Now we have a choice now. Okay. Now this is the IP protocol, IP packet. This is a header, and this is payload. Now what we have done so far, we have discussed so far, is that we are going to encrypt this. Fine. So Bob's machine can decrypt. What else is required? Header is still naked. And we have seen now, in last class, we have seen anybody can change source address. So can we encrypt this also using the same key?
Just a small doubt. Like, if it is encrypted, then what about the address? Like the address handles we discussed in the previous classes that the address shouldn't be encrypted, right?
Right.
Going.
Yeah. So in the same packet. Now what I can do is that here you have source address, destination address, other fields, right? Okay. Now what I can do is that, okay, you would have seen a LAN machine is here that is sending a packet, and this is the gateway. Similarly, and in between is your internet, and this again is your LAN, and this is a gateway here, receiving gateway. Okay. Now I can say that this IP address of this can be source address. This is destination address. Got it? So now what I can do is that I will take this. Okay, so this is the one here, and add on top another IP packet. Basically, this becomes a payload of another IP packet, and here I will put source address as gateway address. This gateway address A, for example, and this is gateway address B, and destination as gateway address B, and other fields, and send it, right? So now what we are doing is that we are creating a tunnel between these two. Okay, all right, got it? So in this way, if we just encrypt payload, then we are not doing the right job. Okay, now we encrypt the header also, and who's going to encrypt is only gateway who can encrypt, otherwise packet will never reach here. So now packet normally as it is, IP packet over Ethernet goes to gateway, and gateway does processing. At the other end, gateway will remove all these overheads of IPSec and give the normal IP packet here. Okay, so that's one way. What could be other way? Okay, now this is what we have discussed is about authentication. Okay, sorry, encryption. How do we authenticate, and what part we can authenticate? All right, we have already this. Okay, so this is inside other IP packet. Okay, so we are now all these parts. Okay, this plus some header that it has, some parts of the header also we can, which we call IPSec header. Okay, so we will have IPSec header here and normal IP header. So part of all this we can calculate HMAC and put that code somewhere here, and so recipient node can find out whether it has received correctly or not. So we can do encryption plus authentication. Okay. Now, okay, this is what this is happening when gateway to gateway traffic is moving in tunnel mode. Now there is other possibility that source say that, like my machine is not capable of creating very special headers, right? So this gateway model works, and this is how we use VPNs. Like, okay, but there is also a possibility that your machine can generate IPSec header, right? So then your machine directly can create, it can do IPSec header, and this is actual IP header, and then this can be payload. So now we have choice that do we want to do encryption plus authentication, or we just want to do authentication. Okay, and then we have more choices where to do it, from laptop directly or source, or do it from gateway. So now we have these choices. Okay, now who is going to decide what is to be used? Again, Tu and Alice and Bob's machine, when they are negotiating in the beginning, they will decide it. All right, now we have designed almost everything. Now let's see how we can do it and what are the details like, right? All these points we have discussed, right? We need encryption, HMAC, digital signature certificates. This of course we will not bother in this lecture. Okay, then somebody has to decide whether to do DES, AES within that ECB mode, CBC mode, CTR mode. All this we have studied. Again is part of negotiation between two entities, right? So first phase in general in this algorithm is negotiation between two entities. Of course, we are going to do use Diffie-Hellman algorithm for key exchanges. All right. So all this we have already discussed. Now, when we provide security at higher layers, then we use IPSec at network layer and SSL at transport layer. Okay. All right. So now let's focus on IPSec. Now note that TCP applications are in user space. In an OS, you have done course on OS. There are two areas, of memory, right? When an application area and OS area, system area, right? Now all these activities of generation of TCP packets, etc., then IP packet, IPsec packet, IP, etc., all these happen in OS. Okay, in the control environment. Application like you have, whatever application, streaming application or file transfer application, etc., or HTTP application, they all work at user layer or application layer. Okay, so it means now when we have to provide security using IPsec, the OS has to be tweaked to include IPsec functionality. Okay, all right. So that's it. What we have discussed is that IPsec's philosophy is that if you do this in OS layer, then all applications layers are automatically provided with security. So you don't need to modify applications. Okay, so what is application of IPsec protocol? So IPs, if suppose you IIT Mandi, okay, IIT Mandi has a campus, North Campus, okay, South Campus, and there may be some other campuses. Okay, you are running a LAN here, LAN North, LAN South. How do you connect these two LANs such that it become a single LAN? Now you can do it over IPsec. Okay, so basically branch offices or an employee may want to connect to an office can use IPsec. Basically, it provides a VPN. I'm sure you would have used VPN, right? Okay, so we can achieve authentication, confidentiality, and so these are the main functional areas of IPsec: authentication, confidentiality, and key management. Secure exchange of key, mainly by Diffie-Hellman. Okay. In addition to that, so basically it should verify sources of IP, basically source address verification, such that nobody else poses as Alice and sends packet. Then authentication, integrity and confidentiality, and it should also prevent replaying of old packets. Now this is another major defect in protocols, right? Okay, and we have not studied this, but please remember it. All right, so these are all we have discussed, right? Okay, so now the basic, if you look at go to drafts where IPsec is defined, is called domain of interpretation. Basically it defines two types of protocol: ESP protocol or EH protocol. ESP protocol provides encryption plus authentication. This provides only authentication. So we have two protocols, ESP and AH. Okay, all right. And then of course there is key management protocol like Diffie-Hellman, etc. Now we have, as we have discussed, the users are given lot of choices, and these choices are negotiated between Alice machine and Bob's machine or two-end machines, right? So we have ESP protocol, which provides which is called encapsulating security payload, which provides both encryption and authentication. Or if you want only authentication, then you can use AH protocol. Then you can use AES or DES. Okay. And then you have, for authentication, you have MD5 or SHA. Okay. This is basically HMAC. Okay. And Diffie-Hellman for exchange of keys. So you have ESP or AH. Basically, ESP plus AH is, you can do both encryption and authentication. Now, it also provides only encryption scheme, but it's not very popular. Then you can choose DES, 3DES, AES for symmetric key encryption. Then you can choose for authentication MD5 for SHA. Key exchanges, there are various protocols. The versions of Diffie-Hellman is available, DH1, DH2, DH5. You can choose any one of these. Okay. Use case is that access VPN that you often use when you go home and you want to securely connect it to company's office, then you use access VPN. Okay. So mobile workers can connect to office through this, or mobile worker internally can connect to each other. User regional remote office can connect to main office securely, and so on and so forth, right? So now in terms of IPSec, you can see if there is a user here, say Alice, and Alice machine can create IPSec header. Okay. This is IPSec header. We'll see what IPSec header contains. Then this machine will create IP packet, the source destination address, IPSec header, and payload, secure payload after encryption. So that can go to a gateway. This gateway will do all the processing, right? I mean, decrypt the packet, do check authentication check, etc., and give the normal packet to local area network where Bob's machine could be there, right? Similarly, if Bob's machine cannot create IPsec packet, it will give just plain IPsec packet to gateway. Gateway will encapsulate it inside another packet and send it. And receiving end, same thing will happen. Gateway will remove this, decrypt it, authenticate, check, and create the normal packet that was here, and that packet can go to destination. All right. So these are the two functionalities. Either your machine can create IPsec packet, it can encrypt the packet or do authentication, do some kind of authentication. Okay. And then create this IPsec packet and send it. So that's then one possibility is that. Otherwise, you give it to gateway and then gateway will create all that. Okay. So this same thing that we have discussed, host A creates normal packet and give it to gateway. Gateway creates this kind of packet. Okay, which will have field corresponding to IPsec, and will go over internet, and this gateway will process it. It will remove IPsec header and give normal IP packet to destination. Okay, this packet will reach to destination. So it's very simple. Okay. All right. So this you read by yourself. So IPsec architecture has basically few components. First is internet key exchange like Diffie-Hellman. Okay. Then it has a protocol called ESP, which is encrypt and authenticate. It's called ESP because its full name is encapsulating security protocol. Or if you want only authentication, then you have it's called authentication header, AH. Okay. All right. So now we will not study AH. We will study, because we have just 20 more minutes, we will only study ASP. If you want, you can read about AH from any paper. Okay. Now we have seen two modes of propagation. Here, okay, when machine can generate IPSec packet, okay, that's called transport. And the one where gateway will generate IPSec packet, that's called tunnel. Okay. Now in these two, we can either use ESP, encrypt and authenticate, or we can use authenticate. Okay. So basically we have 4 combinations, and out of which Bob's machine and Alice machine can negotiate what they want to use. All right. Okay. So we will study only ESP mode, where gateway will, okay, ESP mode where we will encrypt and authenticate. All right. Now the architecture is as follow. There is internet key exchange, which is nothing but Diffie-Hellman algorithm. Okay. Then we have something called security policy database. Now once IP packet is received, for example, when IP packet is generated, based on something, a decision has to be made whether it has to be encrypted or not. See, for example, your machine, when you're connecting to IIT Mandi office and over a tunnel or over a IPSec, okay, your machine is also generating packets which is going to somewhere, right? Maybe Google or somewhere, and you don't want IPSec for that. Okay, so this database will look at some parameters like what is your source IP address, destination IP address, whether the TCP, then what is the port number, etc., etc. And based on that, it will decide, okay, this packet needs to use IPSec. Now, if that is so, then it has to decide what are the negotiated parameter. If the destination is Bob's machine, it will say that use AES, then use some key size, and then they would have, Alice and Bob's machine would have decided what is the actual symmetric key, and all these parameters it can be seen from here, and then that processing can be done, and then packet can be sent. Okay, so now this is called, what all parameters that have been agreed between two machines, Bob's machine, Alice machine and Bob's machine, is called security association. Now this is security association is for one session between two machines, right? It will define whether is using a ESP or AH, and what is encryption method, okay, whether is using a Diffie-Hellman 1, 2, 3 or whatever. All these parameters will go in security association. Okay, all right. So we can see here the security association for, now this is of course is a tunnel mode. Security association is define source IP address, destination IP address, destination IP address, source IP address, destination IP address, then type of encryption used, encryption key, authentication key, etc. This is for one session between two entities. So it means that this machine here and the machine here, router here and router here, should have same understanding for this session between Alice and Bob. Okay, got it? Any question? Are you able to understand? Or is it going too fast? Yeah.
We are able to understand.
Are you able to? Yes or no?
Yes.
Okay, all right. Now it means that now security assertion is formed and communication can happen. Okay. All right. And where this, there can be many such security association. Okay, it has to be kept somewhere. These understanding, we call that database is security association database, SAD. Okay, security association database. So now we'll keep all these association understanding in a database called security association database. So it is a database which will have many entries corresponding to many security association. SA1 will say between source address, destination address, port number, etc., etc. And then what are the keys, right? What are the parameters? Okay. And now when you are sending this packet, right? So now when this packet reaches to Bob's machine, Bob's machines needs to know, or gateway needs to know how to unprocess it, how to decrypt it, how to authenticate, check it, right? So it has to use same parameter. So some index can be sent of this database. Okay. So when this understanding between Bob's machine and Bob's gateway and Alice's gateway happens, Bob's gateway will say, okay, we have agreed on this. Now this is the index you should use next time when you send IP packet. Because this index which Alice's gateway is going to send will be corresponding to database of Bob's machine. Then Bob's machine, Bob's gateway, when it receives the IPSec packet, will use that index to find out these are the parameters for decryption, etc., or authentication, and can do the needful. Okay. Okay. So we call this as a unique security parameter index. Okay. And you talked about security policy, right? So policy defines that what packets that are coming from IP packets need to go to which, for, you know, if IP packet is received by gateway, IP packet corresponding to Alice, which she is sending to Bob, then this database, when it goes to database, database will look at all these parameters, okay, and decide what SPI should be used, or security association should be used. Okay, what security association should be used for that, decided by this one. So we can now see we have security assurance database and security policy database. Okay, so so please go through this. This is something that we have discussed. So security association is nothing but security SPI. Okay, SPI is index. Okay, is security parameter index. Then destination IP address and IPSec protocol, whether it's ESP or AH. That more or less defines SA. So now we can see how it works. Okay, the same thing. Okay. Now please go through this. You know, I mean, basically, IP packet contains a field where we can define what kind of packet is contained inside, right? Okay, so now when you're creating a packet inside a packet or putting external packet, then you would say that inside is IPSec packet. So you will see a code here corresponding to this. Like inside IP packet can be TCP or UDP. Similarly, it can be IPSec packet. Okay, ESP or AH. Now flow is as follows. Okay, Alice is sending, this is Alice's machine. This is Bob's machine. Alice is generating IP packet. Alice machine is generating IP packet. Obviously, it will have a lot of parameters like source address, destination IP. What is inside protocol that's using TCP, UDP, what ports, and so on. So this packet goes to SPD, security policy database. Now, security policy database, looking at all these parameters, will say that, okay, this particular security association is to be used. Okay, and it basically it's SPI. It will say that its index, say for example, 2 is to be used. Okay, so the index is this one. Okay, and then the machine or gateway will read all these parameters and process the IP packet like encryption or authentication, etc., and create and send it to Bob's machine. All right, and it will also add to that SPI of Bob's machine. So Bob's once looks at the Bob's machine or gateway looks at SPI, it will know what are the parameters to be used for decryption and authentication. Any question? Is it too fast? Okay. What happens when Bob's machine receives it? Bob's machine receives packet from Alice's machine, which is encrypted, which is IPSec form. Okay. It will read this contains SPI. Okay, the received packet will contain index of the database, which is Bob's database. You look at that index, get the details, okay, and then check whether it complies with the policy, and then the process the packet to get the original IP packet. All right. Okay. All right. Question? Very fast. Okay. Now let's look at some of the protocols. Please go through this PPT. I mean, lot of information is there. Please, once you divide the problem, multiple problem. First phase is of course negotiation of parameter and protocols, whether we are using ASP or AH. Okay. Of course, we are not discussing AH here. Okay, and this negotiation parameter is through IKE. Once this happens, then only thing left out is that whenever the packet comes from top, process the packet before sending it, basically create IPSec packet and send it to other end. In order to create IPSec packet, you'll have to look at the policy database, and from that you get an index such that where you will find all the negotiated parameters. Okay, with Bob's machine. So you can process the packet and send it to Bob's machine. Bob's machine will receive it. It will get, it already has an index in the received packet corresponding to that index will in the database will correspond to various parameters. For example, what protocols are being used, what is the key, decryption key, what is authentication key, and do all the processing and then give the packet, unprocessed original packet to the application. Okay, so we'll quickly look at ESP. Okay, so the ESP corresponds to encryption and authenticate. Okay, encrypt can be using one of these methods, whatever has been discussed, whatever has been negotiated between two entities. Okay, now we have seen there are two modes, transport mode and tunnel mode. Let's focus first on tunnel mode, which is between gateway to gateway. Okay, so let's look at it. Now note that this is between one gateway to another gateway. All right, so what's happening now? This is the original IP packet. Now note that this is the LAN. So this is Alice's machine, this is the gateway. And one gateway to another gateway it goes in a tunnel mode, which is encrypted and authenticated. So Alice's machine generates something that's shown here. I'm sorry, not the last one. Here, this is the original IP packet. Okay, this is original IP packet. Okay, now what is to be done? Okay, this is to be encrypted. Okay, okay, now we add to this ESP trailer. Okay, we add to this trailer. Now, basically it will say what is going to be next. This is very important field here. That what is the next header? So what happens is that this original, we have created a IP header, new IP header here. This new IP header will say that here what is the content inside, will say that content inside is corresponding to ESP. But now this payload of original IP packet may contain TCP or UDP. Then it will say that, all right, so this header here will say that now what is inside here is TCP or UDP. Okay, forget about it, right? So what we do is that take this packet, create ESP trailer, okay, trailer is like this, and then encrypt this using the key which has been negotiated, okay, and now add to this ESP header, because now it will have index corresponding to Bob's database and sequence number. Sequence number is required to avoid replay attacks. So now to this you add a new IP header. New IP header corresponds to gateway source IP, gateway destination IP, and so on, port number, etc., right? Okay, all right. And now you do authentication or do HMAC or HMAC MD5 of this. Just a minute. Okay. Okay, up to this point, and then keep that here. Let me see, just all right, so basically it will I need to recheck it. It should be up to this point. You will calculate the authentication and then put the data here. Whatever authentication code you get, you put it here. Yeah. Okay, all right. Okay, when this packet reaches to other end, what it will do? First, it will do verification of all this. First, it will do ESP check. It will do sequence number check, integrity check, and decrypt it. Okay. Okay. Now this header and the header here, ESP header, is not, this ESP header which contains SPI and sequence number is not encrypted. So it will go in decrypted form. But knowing this, because if the mallory looks at this IP address of gateway, it cannot do much. Okay. But note that original IP packet is completely encrypted and authenticated. So if something, mallory changes something here, now authentication code will not match with something that's here. Okay, obviously mallory doesn't know the keys, so there will be mismatch. All right. Okay, any question? Okay, all right. So when we are, of course, we'll not discuss the transport. You read by yourself transport mode. So when you are using tunnel mode, what we are going to, we'll take this IP packet, put it here, encrypt this, okay, attach IPSec header, and of course there will be a trailer, and then attach new IP header and just transmit. Okay, all right. So it's something like this. All right. So take this original IP packet, Okay, and then attached to this ESP trailer, because this will have this additional field, we will say what is inside here, and then all this you encrypt using the key that's known to both Bob and Alice, and then you add ESP header, which say SPI of Bob's database, SP database, and sequence number, and authenticate all this. Okay, and add to this new IP header corresponding to a gateway of recipient machine. Okay, so it's like this. If you are going to use tunnel mode, there is no IPSec between Alice machine and Alice firewall, or we call it gateway. This is another gateway. Okay, the packet goes in tunnel mode, which this kind of in this format, and this IP, new IP header corresponds to transfer between this machine and the machine. At this machine, authentication check happens, then packet is decrypted on, then original packet that Alice creates is sent to Bob. Okay, all right. So this is about tunnel mode. All right, so this is a simulation which says that Alice's machine sends normal IP packet. Now this becomes encrypted and authenticated with authentication code IP packet, and then it reaches this gateway. Will remove, do the processing. If it's turns out to be good, send it to Bob's machine. All right, okay. So this gives you the complete flow. Now here you can see the complete format. It's only thing is that this next IP header changes. All right, or here the original, at the top, whatever, there is a field that shows what is inside the content here. It will corresponding now to ESP. All right, so now somewhere we need to create a field will show what is inside here, whether it's a TCP UDP, that we change the value here, that we define the value here. Okay, all right. Okay, so this gives the steps. Similarly, we can have transport mode, wherein in transport mode, which is host to host, not gateway to gateway, you use the same IP header. This original header which Alice's machine creates, use the same IP header here, but in between insert IPSec header. Okay, now this goes in plain as it is, right? Now somebody can change here the source IP address, etc., etc. However, so that's the weakness here. Okay, so this mechanism is used primarily to provide security to higher level protocols like TCP, etc., right? Because here what is protected is this one, payload, which contains TCP or UDP payload. All right, so you can read this, and exchange is very simple, that we have already studied is Diffie-Hellman. Okay, and Diffie-Hellman is used to create understanding or security association between Alice's machine and Bob's machine, or Alice's gateway and Bob's gateway corresponding. So it creates understanding or creates a security association. Okay, please. So we have two phases. First, all these exchanges happen where keys, shared keys for encryption and authentications are exchanged, and then this IPsec tunnel is formed, and then exchange of messages happen between Alice's machine and Bob's machine. All right, so these are the algorithms, very simple. Okay, any question? I know I have gone very fast, but just